morning, friends. In chapter 13, kinetic theory, already we discussed about the ratio of the two specific heat at constant pressure and constant volume. That means the ratio of the Cp upon Cv for different type of the gases. For monoatomic gas and also the diatomic gas with the rigid rotator, we discussed and we obtained its value. For monoatomic gas, the degrees of freedom are 3, and for monoatomic gas, the ratio of the Cp upon Cv, that means the gamma is equal to 1.67, already we obtained. The similar way, for diatomic gas with rigid rotator, what is the meaning of the rigid rotator? Already we discussed. The molecule of a diatomic gas is made up of the two atoms, and the separation or the distance between the two atoms is fixed, does not change. Therefore, this molecule is act as a rigid rotator. In that case, it possesses only the linear motion and rotational motion. Right? Three different type of the linear motion and 2 rotational motion. It does not possess any vibrational motion. Therefore, the degrees of freedom are 5 for the diatomic gas with a rigid rotator, and for this type of the gas, that means the diatomic gas with rigid rotator, we obtain the value of the Cp upon Cv is 1.4. After that, if the diatomic gas, the molecule is made up of the two atoms, but the distance between these two atoms is not fixed. That means the diatomic gas with non-rigid rotator, that is also known as the triatomic gas. So how we obtain the ratio of the Cp upon Cv for triatomic and polyatomic gas? Right? Okay. Now the question is that obtain value of Cp upon Cv for triatomic gas. Triatomic gas, that means the diatomic gas and non-rigid rotator molecule. Okay. For diatomic gas, that means the diatomic and non-rigid rotator gas, the degree of freedom are 7. Because the molecule of triatomic or the diatomic gas with non-rigid rotator, it possesses the 3 different type of the linear motion, 2 different type of the rotational motion, and 2 different type of vibrational motion. Therefore, 3 plus 2 plus 2, that means the degrees of freedom are 7. And from the law of equipartition of energy, the energy associated with each degree of freedom is half kBd. Now, what is the meaning of the degree of freedom? What is the meaning of degree of freedom? Degree of freedom, that means the independent motion possessed by the molecule of a gas. The independent or the number of possible independent motion possessed by the molecule of a gas is known as the degree of freedom. So here, the diatomic or the triatomic gas with non-rigid rotator possesses the 7 different type of independent motion. 3 linear motion along the x, y, z, 2 rotational motion, and plus 2 different type of the vibrational motion. Therefore, the total 7 independent motion possessed by the molecule of a diatomic or the diatomic gas with non-rigid rotator. Therefore, the degree of freedom for diatomic gas is 7, and the energy associated with each degree of freedom from law of equipartition of energy is half kV. Half kV. Now, the method are same, already we discussed, wording are also same. Therefore, the internal energy of 1 mole of gas is, the internal energy of 1 mole of diatomic gas is U is equal to half kBd into number of freedom into number of molecule in 1 mole gas. In 1 mole gas, the number of molecule is equal to Avogadro number. Therefore, U is equal to internal energy of 1 mole gas half kBd into Na into F. But we know that Kb into Na, that is the universal gas constant R. Therefore, we substitute instead of the Kb into Na, we substitute the R. therefore half FRT. That is the internal energy of 1 mole of gas. Again, the internal energy of 1 mole of triatomic gas is half kBT into Na into F. But we know that kB into Na is equal to R. Therefore, U is equal to half FRT. That means the F by 2 RT, or the FRT by 2. But for diatomic gas or the diatomic gas with non-Z rotator, degrees of freedom are 7. Therefore, internal energy is equal to 7 by 2 RT. That is the equation 1. Now, the definition of specific heat and constant volume. Already we defined the specific heat at constant volume and constant pressure, and the relation between the Cp and Cv is R. Cp minus Cv is equal to R. Now, the specific heat at constant volume, the equation is Cv is equal to du by dt. That means the derivative of internal energy with respect to the temperature, or the relative change in internal energy with change in temperature. Therefore, du by dt, we substitute the value of U from equation 1, 7 by 2 RT. Therefore, d by dt into bracket 7 by 2 RT. 7 by 2 constant, I is also constant, taken out of the derivative. Therefore, 7 by 2 R into dt upon dt. dt upon dt is 1. Therefore, Cv is equal to only 7 by 2 R. Yeah, again, from the definition of the specific heat at constant volume, Cv is equal to du upon dt. Now, the meaning of the du by dt, the change in internal energy with change in temperature, or the relative change in internal energy with temperature. Now we substitute the value of U. U is equal to 7 by 2 RT. Therefore, d by dt into bracket 7 by 2 R into T. 7 by 2 and R are constant, taken out of this derivative. Therefore, 7 by 2 R, remaining part is dt upon dt. dt upon dt is 1. Therefore, only 7 by 2 into capital R. Now we know the relation between the specific heat at constant volume and at constant pressure. Cp minus Cv is equal to R. From this equation, Cp is equal to Cv plus R. Value of the Cv already we know, 7 by 2 into R plus this R. So I is common, 7 by 2 plus 1, that means the 9 by 2 into capital R. So that is the value of Cp. That is the value of Cp. That is the value of Cp. Now taking the ratio of Cp to the Cv. Therefore, Cp upon Cv, that is known as the gamma. Gamma is equal to 9 by 7, because here 9 by 2 R upon 7 by 2 R, I by 2, R by 2 cancel, remaining is 9 by 7 is equal to 1.28. Thus, for diatomic gas or the diatomic gas with non-acid rotator, diatomic gas, here the non-acid rotator, the value of ratio Cp upon Cv is gamma is equal to 9 by 7 or 1.28. Clear this? All are same, only we have to substitute the degree of freedom, value of degree of freedom F. Other methods are same, whatever we perform for monoatomic and diatomic with acid rotator, and here there is the diatomic with non-acid rotator. Anyone may be asked for the 2 marks question. That is important. Now next, obtain the value of Cp upon Cv for polyatomic gas. Polyatomic gas, that means that here the numbers of the atoms forms the one molecule. At that time, how we can obtain the ratio of the Cp upon Cv. Now, first we have to know about that the how many degrees of freedom possessed by the molecule of polyatomic gas. For that purpose, the polyatomic gas, the 3 linear, 3 rotational and F vibrational motion. The polyatomic gas has 3 different type of the linear, 3 different type of the rotational and F different type of the vibrational motion possessed by the molecule of polyatomic gas. Then the total degree of freedom for polyatomic gas will be 3 plus F. Why here the F vibrational motion? Because here the numbers of the atoms in polyatomic gas are not fixed. According to the number of atoms forms the molecule. So there is depends the different type of the vibrational motion on the number of atoms. For polyatomic gas, the number of atoms from the molecule are not fixed. Suppose the F atoms forms the one molecule, therefore F different type of the vibrational motion possessed by the molecule of a polyatomic gas. Already in diatomic gas with non-azidotator, here the 2 atoms form the molecule. At that time, the molecule of diatomic gas with non-azidotator perform the 2 different type of the vibrational motion. For polyatomic gas, the molecule is formed by the F number of atoms. Therefore, F vibrational motion possessed by the molecule. 3 linear motion, 3 rotational motion plus F vibrational motion. Then the total degree of freedom will be 3 according to the linear, 3 according to the rotational motion plus F according to the vibrational motion. So 3 plus F are the degree of freedom for polyatomic gas. Now, from law of equipartition of energy, the energy associated with each degree of freedom is half kVt. Energy associated with each degree of freedom is half kVt. Therefore, the internal energy of 1 mole polyatomic gas U is equal to 3 plus F into half kVt into N. Again, according to this equation, half kVt into number of atoms into degrees of freedom. Here instead of the F, degrees of freedom are 3 plus F. 3 plus F. Now, therefore, internal energy U is equal to 3 by 2 kVt plus 3 by 2 kVt plus F times kVt into NA. Now, from the bracket, the kV is common. kV is common. Therefore, 3 by 2t plus 3 by 2t plus Ft is equal to kV into Na. kV into Na, that is the universal gas constant. Also T constant, instead of the kV into A, that is the R. Now, 1 times half 3, again half 3, therefore both combined, so complete 3. Therefore 3T plus Ft. T is common, therefore 3 plus F into RT. 3 plus F into RT. That is the value of internal energy of 1 mole of polyatomic gas. Again, for the polyatomic gas has the 3 linear, 3 rotational and F vibrational motion. Then the total degree of freedom is 3 plus F. From law of equipartition energy, so energy associated with each degree of freedom is half kVt. Therefore, the internal energy of 1 mole polyatomic gas is U is equal to half kVt into F into Na. Here the degree of freedom are 3 plus F instead of this F. So half kVt into Na into 3 plus F. Now we take the Na into half cavity inside the bracket. Therefore 3 by 2 cavity plus 3 by 2 cavity plus F cavity into Na. Kb is taken out. Therefore 3 by 2 T plus 3 by 2 T plus Ft into Kb Na. But the Kb into Na, that is the universal gas constant. Therefore this half plus half 1 times. Therefore 3T plus Ft is into R. T is taken common. Therefore 3 plus F is equal to R into T. That is our equation of internal energy of 1 mole polyatomic gas. Now from the definition of the specific heat at constant volume. So definition of specific heat at constant volume, Cv is equal to du by dt. We substitute the value of internal energy here. Therefore d by dt here. Instead of the U, 3 plus F into RT. So 3 plus F into RT. Now listen, 3 is constant, F is constant, I is also constant, taken out of this derivative. Therefore 3 plus F into R into dt upon dt. dt upon dt is 1. Therefore value of Cv is 3 plus F into R. That is our equation number 2. And we know that Cp minus Cv is equal to R. Therefore Cp is equal to, take the Cv in this side. Therefore Cv plus R. Substitute the value of Cv, 3 plus F into R plus R. R is taken common. Therefore 3 plus F plus 1 into R. 3 plus 1, 4. 4 plus F into R. Again, Cp is equal to Cv plus R. Value of the Cv, 3 plus F into R plus this R. I is taken common. 3 plus F plus 1 bracket over into capital R. 3 plus 1, 4. Therefore 4 plus F into capital R. That is our third equation. Now taking the ratio of equation 3 to 2, Cp upon Cv. Therefore 4 plus F into R upon 3 plus F into R. R are cancelled. Therefore 4 plus F upon 3 plus F is the equation for polyatomic gas. So this equation represents the ratio of the Cp upon Cv for polyatomic gas. If F degrees of freedom is 6, F is equal to 6, then Cp upon Cv is equal to gamma is equal to 4 plus 6 upon 3 plus 6, that means 10 by 9. 10 by 9. So 10 by 9, that means the 1.1. For the polyatomic gas has the value of the Cp upon Cv is 1.1 if in polyatomic gas molecule is made up of the 6 atoms. Made up of 6 atoms. At that time, the ratio of Cp upon Cv is 1.1. Cp upon Cv is 1.1. Clear this? Only keep in mind that here the degree of freedom for polyatomic gas is 3 plus F. Therefore, internal energy of 1 mole of polyatomic gas is half kBT into Na into bracket 3 plus F. So we simplified, we obtained the equation of the internal energy is 3 plus F into RT. After that, we substitute in the equation of the specific heat at constant volume, Cv is equal to du by dt. Instead of the u, we substitute the value 3 plus F into RT. 3 plus F into R common, therefore dt upon dt is equal to 1. Now Cp minus Cv is equal to R, therefore Cp is equal to Cv plus R. Now the value of Cv is 3 plus F into R. Substitute here 3 plus F into bracket R plus capital R. I is taken common, therefore 3 plus F plus 1 bracket into R. 3 plus 1, 4 plus F into R is the value of Cp. taking the ratio of Cp and Cv, Cp upon Cv is equal to 4 plus F into R upon 3 plus F into R. Cancel 4 plus F upon 3 plus F. Is the ratio of Cp upon Cv for polyatomic gas. Right? As you consider the F is equal to 6. F is equal to 6, that means the molecule of polyatomic gas is made up of the 6 different atoms. At that time, the Cp upon Cv is equal to gamma is equal to 4 plus 6 upon 3 plus 6, that means the 10 upon 9, that means the 1.1. 1.1. Right? Okay. Now the next question. Obtain the equation of Cp upon Cv4 is equal to gamma in terms of the F degree of freedom. We are interested to obtain the general equation of Cp upon Cv in terms of the degree of freedom F. Right? Okay. For that purpose, here, consider a given gas has the degrees of freedom F. Again, we consider the one gas having the degree of freedom F, and the energy associated with each degree of freedom is half kBd. Therefore, the internal energy of 1 mole of gas is U is equal to half kBt into F into Na. That means the half F RT. Half F RT. Right? That is our equation number 1. Now again, we are going to discuss about to obtain the general equation of the Cp upon Cv is equal to R for a gas having the degree of freedom is F. For that purpose, we consider a gas has the F degree of freedom, and from the law of equipartition of energy, energy associated with each degree of freedom is half kBd. Therefore, internal energy of 1 mole of gas is U is equal to number of degree of freedom into half kBd. Half kBd is the energy associated with the each degree of freedom into Na. Na is the number of molecule in 1 mole given gas. So it's equal to half FRD, because Kb into Na is equal to universal gas constant R. Here we substitute this. Therefore, half FRD. Half FRD. Now, specific heat and constant volume. Specific heat at constant volume Cv is equal to du by dt. Here we substitute the value of U. Therefore, d by dt, U is equal to half FRD. Half constant, F constant, R constant taken out. Therefore, half FR into dt upon dt, that is 1. Therefore, half FR, that is the value of C. That is the value of C. And we know that Cp minus Cv is equal to R. Therefore, Cp is equal to Cv plus R. Substitute the value of Cv from equation 2, half FR plus R. Half FR plus R. R is common. Therefore, F by 2 plus 1 into R. That is the equation of Cv. Equation number 3. F by 2 plus 1 into R. Now, taking ratio of Cp upon Cv. Therefore, Cp upon Cv is the gamma is equal to Cp value is F by 2 plus 1 into R upon F by 2R. So here we add to this F plus 2 upon 2. 2 is the LCM in the numerator. Therefore, F plus 2 upon 2 into R upon F by 2R. R by 2 cancel. Therefore, F plus 2 upon F. So it's equal to 1 plus 2 upon F. That is the value of, or the equation of the Cp upon Cv is equal to gamma for a gas having the degree of freedom. So it's the equation of Cp upon Cv in terms of F, in terms of degree of freedom F. Clear it? Very easy. That is the general equation of a ratio Cp upon Cv in terms of the degree of freedom. If we substitute the different value of F, we can obtain the different value of Cp upon Cv for different gases, like as the monoatomic, diatomic, residuator, diatomic, non-residuator, and also for polyatomic gas. Again, consider a gas having the F degree of freedom, and from the law of equipartition energy, the energy associated with each degree of freedom is half kBT. Therefore, internal energy of 1 mole of gas U is equal to number of degree of freedom, energy associated with 1 degree of freedom into number of molecules N. So half F into half kBT into Na, but kB into Na is the universal gas constant capital R. Therefore, half F RT. Now, specific heated constant volume Cv is equal to du by dt. We substitute the value of U. Therefore, d by dt half F RT. Half F R is common constant. Therefore, dt upon dt, that is the 1. Therefore, value of Cv is half into F R. Now, the Cp minus Cv is equal to R. Therefore, Cp is equal to Cv plus R. Cv is half Fr plus R. R is common. Therefore, F by 2 plus 1 into R. Now, taking the ratio of Cp upon Cv. Cp upon Cv is equal to gamma is equal to F by 2 plus 1 into R upon F by 2 R. I by 2 cancel. Here we take the first LCM, F plus 2 upon 2 into R, and F I by 2 cancel. We obtain the F plus 2 upon F. Therefore, 1 plus 2 upon F is the equation of the Cp upon Cv for a given gas having degree of freedom R F. Clear it?